So let's continue, ladies and gentlemen. Our next speaker is Ari Pouttu, Director of 6G Flagship and Professor of Communications Engineering, Dependable Wireless Communications more precisely. And the title is 6G Flagship, Retrospective and Forward Look.
Okay, so I guess this one is the remote control. It's very nice. It says back and next. It probably works also for an engineer because it's like a binary, zeros and ones. Okay, good morning everybody. My name is Ari Pouttu, as mentioned by Markku, and I'm the director of 6G Flagship since the 1st of July. Matti, our previous director, became vice rector of research of the University of Oulu, so he has moved on into bigger circles. So I will first introduce some details about the 6G Flagship, and I have then few exemplary slides of some of the experimental work that we have been doing. I'm not going to deep delve into integrals and solutions for MIMO or anything like that, but just tell mostly about the program itself, and then few examples of experiments that we've done, and then later a couple of notions on what kind of technologies are there in 6G networks that can provide resilience. So we've been building these networks so that we have had every 10 years a new G, as they say. The 4G was the first one that brought the internet into our pockets, and they had a slogan, always best connected. Then we had the 5G, which was supposed to be the, let's say, the messenger of bringing in the Internet of Things or the devices into the mobile cellular world, as well as the process control and these kind of issues. And it partially is there, but partially it was left for 6G, which is basically now in its inaugural phase in terms of standardization. The first 3GPP meetings have been held on defining the study items and to look what kind of system 6G will be. But we know already now that there is this immersive part of the high data rate communication, which is easily translated into metaverse and digital twins kind of an environment where the cyber-physical connection between the real world and the digital world can be made, so that we can sense the environment and actuate it from these digital environments. And what's coming next? This is what we've been thinking, is that it's about resilience, it's about sustainability, and it's about AI-driven technologies. So, and on top of that, we do believe that the network has to be sentient, beyond just RF signals sensing, introducing multimodal sensing into the 6G fabric. So the program itself is coming to an end next year, and we are applying for continuation, which may start already 2027 early. The program has been rather large. It's when we calculate all the projects that are related to the program, the full, let's say, budget of the program is close to 300 million euros. And it's operated by our university only. There are no other funding, well, partners receiving funds, but a lot of ecosystem partners, more than 1,000. There are 400 companies and maybe 700-800 academic partners, and then governmental partners as well. Currently we have something like 570 researchers coming from 54 nationalities, and we have provided now 14 white papers with a huge amount of downloads, which is something that makes us really proud and made us the opinion leader for several years in the 6G domain. We have the program divided into 4 strategic research areas. The first one is looking at the radio access networking technologies, meaning what are the needed magic tricks that you make the bit right, the radio wave. So how do you combine the data and the electromagnetic world? So that's one of the biggest areas. We look at modulation, coding, MIMO technologies, integrated sensing and communications, these kind of things are there. Second part is these devices and circuit technologies. Our first and initial guess was in the 2018 that there will be a part of 6G that will look at higher frequencies, up to 300 gigahertz. And most of our device and circuit work has been concentrated on 140 and 300 gigahertz region. Now, the problem obviously there is that the semiconductors of today do not actually provide power. So the design paradigm has been totally changed into new type of circuit designs. And we would actually need in the future also new type of semiconductor materials. However, now we know that the 6G first incarnation will be in lower frequencies, somewhere around 7, 8 or even below. And obviously our device and circuit technologies guys are very strongly now also looking at solutions in that particular region. The third area is about computing, distributed intelligence. So we look at a lot of different kind of ways to distribute the computing into the network. How do we migrate services within the network? How do we do distributed machine learning technologies? How do we combine multimodal sensing in let's say, practical fashion. So these kind of things are there. And then there's the fourth one, which is about verticals, sustainability, regulation, and then we have the 5G test network, which is then used for different kind of tests. And, let's go back one more. We had in the beginning 4 strategic verticals, namely health, industry, vehicular and energy. However, due to the latest development in geopolitical tension, we have introduced this security and defense also into our portfolio of strategic verticals. Internal collaboration is really global. We work with all the continents and all the major players in Europe, but also in Brazil, US, India, South Korea, Japan, Taiwan, Singapore, and Australia. Curiously enough, you don't see China there. That's a, let's say, strategic choice. There are a lot of achievements. These numbers are until October this year. The publications is obviously the bread and butter that we do. So we've had 4,210 some publications over the 6-7 years, a bit more than 7 years. We have also been valued as number 30 in the telecommunications engineering in the world of, academic rankings. A lot of co-creation and business opportunity with different companies. We've had 552 research projects with our partners, 457 company collaborators, out of which 136 companies have been funding our research activities. And then about the societal impact, I already mentioned the white papers. They have been downloaded more than 1.1 million times today. And also the 6G Waves magazine, which you have few examples there on the table, has been downloaded more than 340,000 times. So hence the opinion leadership and the recognition from all different players in the world that yes, we here in Oulu probably know what we are doing. So all of these are in line with the 6G ITUR usage scenario. So there is this immersive, massive and hyper reliable low latency communications which stem from the 5G triangle, and then the new ones are now coming in at the ubiquitous connectivity, so combining the satellites to terrestrial networks. AI and communication, as mentioned, it's now becoming mainstream tools for future connectivity. And then there is this sensing part, integrated sensing and communications. The 5G test network is a tool that we use in many projects, and typically European Union projects require large-scale piloting, and this has been a very good tool to provide these kind of experimentations. We started building this environment in 2015 using 4G technology initially, obviously, because it didn't exist. The first 5G device came to our network in 2018 in Pyeongchang Olympics. We did some of our front-end design, and Nokia provided the baseband devices for this experiment. So that was our first 5G experience. In 2019, we became an operator. So we did receive our first 5G NR base stations, and we have our own SIM production. So we operate similarly the network as any mobile cellular network operator would do. So that's a practical tool to do a lot of experimentation. And we have several avenues how we can use this environment. First one is this commercial operator network solutions, where we can test the different prototype user devices, not just phones. It could be also, for instance, cars or your toothbrush or your excavator or train or camera or whatever device which is 5G enabled. So customers can come into and test their devices in our network. It could also be a testing tool, testing software, an application on your mobile phone. So that kind of opportunities are available there with the commercial operator network solution branch. The next one is software-based network solutions. People talk about Open RAN. It means that all the tools except the radios within the network, the base station, are deployed by using only software. And the software is typically open source, so that's a good tool for changing all the algorithms within the protocol stack of these 5G and 6G systems, allowing us to do more in-depth studies on how changes in certain parts of the network would, let's say, mirror into the performance of the system. And then we do these disruptive technologies, which are like reflective intelligent services and these high-frequency circuits, extreme positioning. So these kind of things are there, which are probably going to be fully deployed towards 2040s rather than 2030s. Some of these integrated sensing and communication things may come earlier. And then the usage of AI and ML is a sort of like an own area by itself. We have NVIDIA-based tools that we can use in that particular domain. So the white papers were there. Then we have this 6G test center. I will not go deeply into this one because we have tomorrow a talk by Hannu Nikurautio, who is the leader of this test center. In this session, Hirleo Alves will introduce this recent, actually today we are launching this white paper on resilience. So Hirleo will introduce this work for you in about an hour or so. Some resilience-related experiment examples next. I just click them through. Drones is one. So we are using a lot of drones and using a lot of 5G-enabled drones doing different kind of demos using the flying platforms. Then we have smart excavator, which can represent a tank, or it can represent ambulance, which is a remote-controlled device. Same with wheel loaders. Energy research, we have a system where we are producing and consuming. So we have base station connected to renewable production, and we try to see how it can work. And the latest addition to this domain is that we are now building a base station where we try whether we can make a base station run year on year without grid connectivity. So we have their hydrogen cells, we have wind power, we have solar panels, batteries, and that remote station should be alive even during the dark Arctic Finnish winter conditions. So let's see how it goes. There are some other result examples available. This you can find in YouTube, 6G Flagship YouTube. There are lighted and air drones, for instance, 3D scanning, terahertz sensing, different kind of demos available there. Now, one of the things that we are now starting to look at is this hybrid network. So there are, for instance, commercial networks that can be connected to civilian authorities network. For instance, in Finland, we have Virve network, which is targeted only for police and authorities in general, even defense forces. And then we have the tactical network. So we are now looking at these kind of issues where we try to connect these in a secure and resilient manner and providing different services with different granularity of resilience in different parts of the, quote, battlefield. And the technologies which we, at least these are some of the technologies which we can use to build in the resilience into the system design. So adaptive antennas, for instance, is a very good tool to provide resilience. Nowadays, adaptive antennas in civilian systems are designed only for maximum capacity, but you can always change the algorithms to provide, for instance, null steering towards interfering source, which decreases the capacity but increases the resilience. There are then unmanned vehicles, drones, radio-based sensing, multimodal sensing, the analytics to detect attack vectors in the network. And that also allows us to process an immense data amounts together with edge computing, battlefield digital twins or similar. And then obviously to bring in the redundancy in the networks, we are looking at integrating the NCN networks on terrestrial networks. So with that, I thank you and invite questions if you have any.
Yeah, thanks a lot for the really informative presentation, especially the slide on like how 5G, 6G networks, they connect to the manets. I mean, that's a very prudent depiction of like how we should view how resilient networking could help in these domains. But I have a question, and then also it sort of raised a concern for me that we are already talking about 7G when the industry faces challenges in monetizing 5G. I mean, I don't want to criticize the research because we have to do research. But then are we jumping the gun in calling out the Gs when rather we should be saying that, okay, how do we optimize what we're doing in 5G and then see where the standardization takes us in 6G and then see what comes next. I mean, all the time we just continue to do the research and see if it becomes, let's say, risk becomes viable for the industry or not, and these kind of things. So just that. And just to give you context, I'm Akshay from No Cable Lab, so obviously I'm from a vendor. So that's
a couple of things related to your comment or question. First of all, you are quite right about the 7G. There was number 7 in the slides, and that was a teaser. We do not know whether 7G will come. We actually, while we were starting the 6G program, industry had already, and Commission had already made up their mind that there will be no 6G. It's only software upgrades to the networks. However, we managed to change their minds, and then 6G comes. Good or bad, I don't know. But the one thing about this obviously, this question is the return of investment for especially for the operators, but also the vendors who provide the network infrastructures. And yes, it might be that 7G is way, way, way out there, but as researchers we can go there. As companies you must be much more careful and look at what happens in standardization. The second question was about the resilience and who's going to pay for that. Well, that's exactly the question that we need to answer. So World Bank and the European Research Institute, which name I don't remember, has done a large surveys and they come up with the number 1 equals 4. So if you invest as a society €1 into resilience, you gain €4. So 2 answers, neither of them are perfect, but kind of motivates why we are doing this.
Yeah.
Thank you. It was a really nice presentation. Thanks for that. My name is Petri Parvinen. I'm working for Baltic Networks. And when we are talking about resilience, I think that there was missing totally the part of the private networks. The private networks are, you know, on the very mission critical places.
Yes. So. That is obviously one of the key enabler for resilience, at least locally. And for instance, this hybrid networking, which was the second last slide, includes that idea. I didn't want to go there too deep, but these tactical bubbles, which are private networks deployed where it is needed. So, but then private networking also can be used in civilian system resilience by providing hospital networks, providing campus networks, providing critical information systems with the private network. So yes, it's definitely part of the storyline.
Most important places like nuclear plants, ports, etc. Like you know, we are island anyway. So
yeah, true.
This is working? Yeah. Yeah, my name is Hakima Chaouchi. I'm coming from France. I'm in charge of the coordination and support action for the 6G standardization of the ecosystem. Thank you very much, Ari, for this very nice and insightful presentation. I have actually a few questions. The first one is private 5G in the resilience approach. Do you think that in a situation where we need to move from the public 5G or 6G, then we can use or reuse what is installed there for private 5G, you know? This is my first question for the resilience enabling connectivity in zones where you have private 5G. And the second question relates to the connectivity, the civil and dual. Do you think that this goes up to the physical layer? Because we know that in critical and dual communication we have dedicated radio frequencies. So does it mean that the future 6G or 7G we will be sharing these dedicated frequencies that are in defense? And the last one is, do you think that 7G will be only 3GPP based technology? Because 6G most probably will be multi-technology, so I believe that 7G will be as well.
Yeah. Well, regarding the public-private networks question, one of the things that need to happen is national roaming or some kind of a roaming deal so that because the customers are owned by the national mobile network operators. So if we want to use these private networks in any other fashion than just closed networks, then we need this national roaming to happen. The second question was again? What was the second question again? Radio, oh yeah. Currently all tactical networks do have their own frequency bands as do the civilian networks, and I don't see in the immediate future any changes there. NATO have their own frequency bands, and then the civilian 5G, 6G systems have their own frequency bands. So going down the physical layer and frequency domain, I would say that the connection happens somewhere in the IP layer or somewhere like that.
Okay, maybe one more question, please.
Good. Hey,
Thank you and good morning. So Niina Hyvärinen from Aalto University, the Center for Knowledge and Innovation Research. My question is less technical but more political, and you've been mentioning the 6G standardization and the work in that area. So I'd be interested in, I don't know, in if you want to comment or in one of the speeches and discussions we are having during these 2 days. But my question is about China. Like where China is in the 6G process, when we talk about resilience, it's quite relevant. But also when we look at the international standardization work, where that is going. I don't know if you want to comment on that.
Well, what I've learned from colleagues working in the standardization, they say that China is really active in 6G standardization. They have a huge amount of contributions, even though many of those are very small, but still they have a lot of contributions there. And I believe the whole community still is looking for and expecting to have a global standard, meaning that China will be also included into this. However, if things get heated enough, China has the home market to make its own standard and survive, but hopefully there will be one global standard, and these tensions that we see blow over time. So let's see. It's a question that I cannot decide, or I can just speculate.
Okay, thank you.
Thanks.